Sorry? Let's say I take two features. The thing is, I have like 10,000 people, I have their height and weight. Right? Given height and weight, I'm guessing. So I'll say I'll input height, weight. Right? Now I need to guess their income, something like that. This is my basic problem setup. I have data for 10,000 people, 10,000 heights and weights. I have to guess income. Now the things inside a neural network is there are neurons and synapses. All a synapse does is everything is connected to everything. You can't like partially connect stuff. A synapse takes input, multiplies by weight. A neuron takes input, adds them up, puts it through an activation function, like say sigmoid or something, and outputs it. Okay? So you need to, your model parameters in linear regression was slope and intercept, M and C. Here it is going to be the weight on this synapse, the weight on this synapse. You need to figure out these two ways. If you have done that, your neural network has learned the model parameters and you're done.
So instead of M and C, it is W1 and W2.
Correct, correct.
What are those weights?
Huh?
This is a neural network for linear model.
No, this is a neural network period.
For linear model.
No, it's a neural network period.
But we are putting.
There is, neural network is a model in itself. It doesn't make sense to say neural network for linear model. Linear is one model, neural network is another model, like that. So basically what you are trying to do in this whole, what this whole thing is trying to achieve is, it's trying to combine height and weight in some way so that it can learn the right income. It could be that what this might end up meaning is 2 times of height plus 3 times of weight, right? That combined with what this outputs, this might be outputting half of weight plus 3/4 of height. This might be outputting 10 times of height plus 20 times of weight. Those combined again will probably lead you to the right value of income. That is some horribly complicated expression with a lot of matrices involved. But at the end of the day, they're trying to just mix and match height and weight and give you income. One very easy way to do is probably 10 times of height plus 20 times of weight will give you the income of a person. But that's not enough. This jumbles it up even more. This tries to find so many more combinations of height and weight to get to the right value of the income. That is basically what's happening here. And your W1, W2 is going to tell you how your height and weight are going to be combined to hopefully give you the right value of the income. Right? So what a neuron does is it puts it through an activation function. An activation function very simply takes a value, converts it to value between 0 and 1. That is all. One activation function called sigmoid is e to the power of x divided by 1 plus e to the power of x.
1 divided by 1 plus e to the power of minus.
Yeah, that will give you the same thing.
Sigmoid function.
Okay, you're doing it.
Yeah. So this, your numerator is always greater than your denominator, and hence this will always output a value between 0 and 1. You take your height like say 7 feet, 6 feet, etc. Convert it into 0 and 1. Weight, convert it into 0 1. Now this synapse just takes input, multiplies by weight, outputs it here. This guy, This guy needs to get 2 inputs. He takes 2 of his inputs, puts it through this activation function. Again, you got a value between 0 and 1. This guy needs to wait for 3 inputs. Waits for 3 inputs, adds them up, puts it through this activation function, spits it up.
And this weights will be different for
This weights, you don't know this weight, right? So guess 0 and 0 first. You got a horrible income, got a horrible prediction. Your error in your prediction is very high. The same way what we did for linear regression,
Right.
you back propagate. In linear regression, we differentiated first with respect to m. Here, differentiate first with respect to W2. Then differentiate with respect to W1. The next time you forward propagate, W1 plus delta W1. W2 plus delta W2. Use new weight values. And your error is a little lesser now. Back propagate again. Differentiate with respect to W2, differentiate with respect to W1. Forward propagate. W1 is W1 plus delta W1. W2 is W2 plus delta W2. Your error is lesser than your previous iteration. So keep going back and forth. How many times you go back and forth? You set it as 10,000 or something.
So then we find the W1, W2 optimum value.
Yeah, optimum.
I was actually going through one tutorial, like they're saying to find W1, W2 when you use gradient ascent or something, come to a maxima, whereas the optimum value you use it.
But you are looking for the minima here. You're looking to reduce the error. It depends on how you have set up your error function.
Yeah.
If your error function is trying to do predicted minus actual, then you're looking for a minima. If your error function is set up to do actual minus predicted, then you find the maxima, go in the opposite direction. So it depends on how your error function is set. But at the end of the day, it makes sense to look for the least value of your error.
Yeah, that's true.
Yeah, so you're either ascending a curve or descending a curve to find that least value. Okay, so now let me just write out the functions. I will let you guys derive it, find the derivatives, and use it in code. Okay, this like just keep this in mind. Unfortunately, I can't keep this and. Or let me draw a much smaller version of it because I keep needing it. Draw a much smaller version. So the first thing is, this is simple. You just activate it, right? You arrive here. Now to go from here to here, the synapse will need to multiply by a weight. I'll call it W1.
And the W1 will be same when you for each of
There are 1, 2, 3, 4, 5, 6 values for W1. Different values. Right? So W1 will look like this.
If the value is same,
It goes like
Yeah, W1 is a matrix
right.
that would look like this. One, two, 1, 3, 2, 1. Right? So these set of weights for the first neuron. These set of weights for the second neuron. And you don't have a clue about any of these values. Right? So similarly, your W2 will look like
then
W2 is a matrix.
we
Yeah, so
I think we.
yeah, when you're using TensorFlow and all, you don't need to worry about all this. Because we are trying to build it from the ground up.
So we have to define all this metrics and synapses.
Yes, yes.
In scikit-learn it is.
Yeah, I mean you have libraries to multiply matrices. At least that you don't need to do by hand. But defining this matrix, at least for now, we are doing by hand because we are trying to learn. Okay, so let's keep a W1. Okay, let's traverse from here to here. Okay, when you have to traverse from here to here, you have 2 inputs, 3 neurons. 2 inputs, 3 neurons. You have your X which comes here. I will call this Z2. My Z2 is X into my X has 2 features, right? There could be 10,000 rows of those features. So my X will look like, so this is person 1, person 2 till person say 1000. And height, weight. This is how my X will look. Height 1, weight 1. Height 2, weight 2. Height 1000, weight 1000. So my X is 1000 by 2, correct? Now when this multiplication happens, this is 1000 by 2 multiplied by 2 by 3, which will give me 1000 by 3. This is how your Z3 will look. So your Z3 will be 1000 by 3. So you come here. Now you are activated. You need to cross this neuron. Z is here. Z.
No, you put that W1.
The weight one. This W.
Okay.
This whole matrix.
So that is the
Yeah, that is 2 by 3. X is 1000 by 2.
yeah, but why you put that 1000?
No, I'm showing the shape of Z. That's all. Just like I don't need to. I'm just
Okay.
showing. Yeah. Now you activate it. You go through an activation function. So I just say sigmoid of Z2. Now I need to go from here to here. Is whatever A2 that I had into this W2 matrix.
This Z2, you have
Z2.
3 neurons are there in between, right?
Correct. That is why this 3 came here.
This is alpha into alpha equal to.
Yeah, this is your activation, the output of your activation. You can call it A, alpha, whatever. Now you came here. Now you come till here, Z3. The final, your Y predicted value is given by sigmoid of Z3.
What do you mean by activation?
This e to the power of x divided by 1
1 by
plus
x.
e to the power of x. So it is just going to take its input, add it up and pass it through this. So you get a value between 0 and 1. We had a whole class on activation functions, but I'm not going into that.
So is it a predefined neural networks for this or can I design our own?
Yeah, there's TensorFlow and all that will give you libraries where you don't need to do anything.
No, I'm just talking about the network what you have drawn over there, right? So can I remove one of the network?
Yeah, the APIs will be I want have only one hidden layer.
Okay.
So this, your input and output is fixed. You can't do anything about it. But you can say I'll have 3 hidden layers. First hidden layer I want 5 neurons. Second hidden layer I want 10 neurons.
So we can customize.
Yeah, you have APIs to customize.
So what is the benefit of putting extra layers? Can you keep it more fine result?
That you just play around with it and see. that there is no good answer to it. It completely depends on the kind of data you have.
Kind of problem.
Yeah. So basically what's happening is you pass it through, you multiply by weight, activate it. Multiply by weight, activate it. The more layers you have, all you are doing is adding steps of multiplying by weight and activating. The dimensions of your weight will depend on the number of neurons that you have configured. That is how a neural network is built. Now, when you have to back propagate, you first differentiate this with respect to W2. So then you come here. Differentiate with respect to W1, you come here. Change W1, W2 by the delta W1, W2. Forward propagate. Back. What I have given here is forward propagation.
So y predicted minus will be or from where I have to do the differentiation?
So your differentiation, your error function J is y predicted minus y actual.
Sorry, but you said we have to come from 1 by 1 step.
Correct. So now differentiate this with respect to W2 and differentiate it with respect to W1.
Sigmoid function will always give you output between 0 and 1.
Correct.
Then y predicted minus y actual value.
Yeah,
is it
so
classic?
even this you'll have to normalize. You'll have to normalize it to
Between 0 and 1.
between 0. So divide every value of y by y max.
Ah, okay.
Yeah. Okay, I've given this
Let's divide by max.
by max. So I have the values I have code for forward propagation, back propagation, and I have the actual values of the derivative as well. So, but I leave it to your interest level. If you want to do the harder derivative and gradient descent of a neural network, or you want to do the simpler one of a linear regression today.
Firstly,
Huh?
let's start with
Linear
the
Start, yeah. So fine, I'll leave it to you. So get linear regression implemented and working. Then calculate the derivatives for your. I haven't even done the derivative calculation for this and that. You saw how easy it was for linear regression. Here you have all these matrices and shit coming in. So it's much harder, right? So I will leave the differentiation also to you guys. Do the differentiation. Have code for all this. I can share it later, and see how well you can perform. Forward, backward, forward, backward, forward, backward, forward, backward.
We have to take care of the dimensions also, right?
Yes, you have to take it.
We have to-
Yeah.
Of course.
Okay, so we have time. You guys can. There are tables around, chairs around. If you want to do linear, do linear. If you want to do neural network, do neural network.
shall I pause the video?
Yeah.